My name is Felipe Hoffa. I speak Spanish. I'm Chilean, so that's pretty cool. I'm going to give this talk in English because we have a lot of English speakers here. But if you have any questions in Spanish, feel free to give me your questions in whatever language you prefer. We're going to be enjoying the next 40 minutes analyzing GitHub data. My name is Felipe Hoffa. You can find me on Twitter. You can ask me any questions there, on Stack Overflow, etc. Are you ready? Are you awake? Excelente. Good. What do you see here? What is this? What's a Python file, a screenshot? Good. It is a screenshot. It is a wall. It's light, but other things we can see here if we zoom in is we can see a license, we can see a copyright, we can see certain imports, certain things from the future. If we go back, if we zoom out, we can find there is a number of issues, there is a number of contributors, there's a number of stars. What I'm trying to show here is that when we look at this, we see a lot of data. We can analyze this data. We can learn things from it. So who wants to analyze GitHub? I hope all of you. Any project maintainers here? Anyone has a popular project? Woohoo! Excellent. Maybe we can analyze them later interactively here. It could be fun. I will take questions at any moment. I will jump to wherever we want to jump. That's the fun of this. So project maintainers want to know how popular the project is, who's following it, will they break other people, is the project healthy? Project users want to know the same thing. Project users want to know how to request features effectively using data. Project choosers, before you choose a project, you want to know what's the most popular alternative. What else could I be using instead? People that love data, I love data, data integrators, language investigators, security researchers. Hopefully you will be interested in the data sets I'm going to show. There are 3 data sets we can talk about. I will be focusing now. GitHub Archive, it has billions of events collected from GitHub hour by hour. GHTorrent, this goes further into the graph of GitHub, collects for example, the locations of users, more metadata that you can use to enrich your data set. And we have also a copy of all the open source code on GitHub in BigQuery that you can analyze at any time. Yep, sounds good. Should I speak slower? No? All good, excellent. Yes? I'm going to show you that now. But before I show you how did we get this data, just as a teaser of the things we can do with it, what are the top companies contributing to open source? Any guesses? That's one. Is that the one that most contributes to open source? Google, I know that one. So there was an article last year that said Microsoft is the one contributing the most to open source. It all depends how you're counting. There are many ways to count things, but my count got to this chart. Here we have the number of GitHub users that I found related to a company. So Microsoft is the one I found more GitHub users for. But on this other axis, I have the number of repositories they're contributing to. And we can see that Google is contributing to more repositories. And the size of the circle is the number of the stars that these projects are getting. So in number of stars, in the number of love that people are giving, Google has a bigger ball circle than Microsoft. And there you have everyone else that they don't come even close to these 2 companies, but they are all pretty cool just for contributing, creating projects, having active users. And to get to a chart like this, I ran a query like this. We should start in a way simpler place, but I just find it fun that if you start with one simple SQL query and you start enriching it and comparing stuff, and you can grow to have this full chart in one query. And if you disagree with the data I got, you can run this query, you can tell me where I'm wrong, you can tell me, no, my company should be in a whole different position. But it turns out no one has said that so far. Well, in fact, IBM, I had IBM in a different position at first, but that's because they use a special kind of email segregation, but I ran a whole new chart for, I fixed this chart for them, and no one else has told me that they deserve a different position. So that's cool, and please fight me if you want to like different results. So where this data came from? Back in 2012, this is my teammate Ilya Grigorik, and this is when he released this project, GitHub Archive. And he started by just collecting every hour all the events from GitHub, storing them on files, and sharing these files. Pretty easy. You want 1 hour of data, you can download right now one of these files. To me, to download one of these files took me less than 1 second, 5 megabytes, January 1st at 3 p.m. If you uncompress the file, this file is about 40 gigabytes of data, and that's pretty cool, pretty easy. Anyone can do that. But if you want to do 7 years at this rate, you will get more than 2 terabytes of data, more than 1 billion events, and that's when things are not so simple. How do you solve this? Okay, you can download all this, but what do you do next? Where would you analyze it? Any favorite tools? Anyone? Any favorite tools? I have my favorite tool. This one. Who knows BigQuery? Google BigQuery. Okay, 1 hand, 2 hands. You know BigQuery. Yeah, come on. And don't be shy. So BigQuery is one of the cloud tools from Google Cloud. Very quickly, one slide. It's fast. It analyzes terabytes in seconds. It's simple. You just need to know SQL. It scales from bytes to petabytes. Just put as much data as you have. There's nothing to turn on. It's just running all the time. It charges for data stored and for queries, but if you're not using it, the cost is 0. And you can work with pandas, with R, Python, Power BI, Data Studio. And the most cool features for me are that if I have data here, data is private. Everything I store in BigQuery is for me only. It has the top security controls. But I can also choose to share it with you. So if I put these 2 terabytes of data and I share it with you, you can instantly all query it. And everyone here, everyone everywhere has 1 terabyte every month for free to run any queries you want. So that's BigQuery. I will show you how it works interactively. That's the fun part. Let's start by looking at stars. What kind of stars? GitHub stars, of course. So let me show you BigQuery in action. I love doing live code, even with 1 hand. So if we want to find GitHub Archive, this is the web UI for BigQuery. Here I have all of 2017. This table has all these fields, and this table has almost 1 terabyte of data in 400 million events during last year. We also can see events for yesterday, but let's look at all of 2017. If I want to look at all the stars during 2017, I just need to write a where. The type of the event is watch event. This is an events table, so everything gets logged here. I can look at the repo.name. It's harder to type with 1 hand. Count star. And now we group by the first column, order by the second one, in descending order, limit 20. So this would be the top projects by number of stars. Oh, I have to, these are options of a previous query I ran. So Show options. I want this standard sequence. Aha. So live debugging is cool because then you can see what kind of problems you can run it. So the top projects by number of stars during 2017 were FreeCodeCamp, TensorFlow, Vue, React, what every programmer should know, developer roadmap. If you notice, we did this query in 4 seconds, over 15 gigabytes of data, 400 million events, and it ran pretty fast. And this is when we need to start being cautious. Is this really the number of stars that each project got last year? Let me give you an example. I'm collecting everything I've written about this in one place. So if you want to the slides for this, come to this repository instead. And here's where you can find everything I know and I have been collecting. So I start my own project. I'm going to remove the star. I'm going to give it a star again, and star, star, and star, star. So what I'm doing here, every time I start my project, I'm generating a new event. And if I'm counting the number of events, I will get a lot more than 9 stars. So now you need to start thinking about how are people could be gaming your stats. And it turns out, instead of counting how many stars each event, each project got, you should be counting how many different people start each project. And with SQL, it's pretty easy. We count the distinct number of actors. Now they are not lying to me, and I can order by that column. And again, every time we run a query, we need to be cautious, we need to be suspicious, and ask if that's the real result. And this query takes a little longer because now we have to remember each actor we saw, but still 13 seconds. And you can see that really FreeCodeCamp got 5,000 less stars than we thought. TensorFlow got less stars. Some projects change their positions. Some projects only have duplicate stars, but you should be doing this kind of analysis. Any questions? Should I continue? I'll continue. Cool, so I have some of these results already on my slide, so let me jump this. Here we can see the 2016 versus 2017. TensorFlow jumped from number 5 to number 2, but still FreeCodeCamp gets more stars than everyone. Anyone knows FreeCodeCamp? Yes, it's all about learning how to code. Yeah, and so you know FreeCodeCamp. You know what the first step in this project is. Start GitHub. Yes, that's how they get so many stars. But they removed that, that step in the second half of 2017, and that's why they stopped getting stars. In 2017, they got half the number of stars, and this year we will see way less. Not all stars are equal. Are all stars equal? Like, can we just count the number of stars? Not really, because when I give 1 star to a project, it's different than when you give 1 star. Every star that each person gives is different because each one has a different background. You have a favorite language. You started on GitHub in 2014 or 2010. You have different interests. So I should not rank projects just by the number of stars. I should rank projects by what audience I'm interested in. Just to give you a more live coding, but let me copy paste this query. Where am I? Here. So in this case, I'm going to take 2 projects, TensorFlow and FreeCodeCamp, and I'm going to compare them by, for example, this is the number of stars that this project got, the number of stars that TensorFlow got, and now I can look at the people that gave each star. So for example, the age in GitHub years, how long ago did they create their GitHub account? People that start TensorFlow are older, they have double the experience that people starting FreeCodeCamp. They have watched 8 times more repositories, they have written more comments, they have written more issues. So you can see that one project is way more mature than the other one in terms of their audience. And that's the way it should be. Free Code Camp is a project for new coders. And if we run our rank again, for example, if we only look at stars given by people that have written more than 20 issue comments, Free Code Camp has almost the same number of stars than TensorFlow. Because most of the issues, more of the stars in Free Code Camp come from a different audience. And the question is, what audience are you interested in? Then you can run your own rankings for what are your goals. So if we compare this ranking where Free Code Camp was the top project, if we only look at the top people that have experience, Free Code Camp is not the top project. Yarn is the top project during 2016. And things move around depending on what you're interested in. Now, when people start something, they have started other projects. You can also run a pretty easy query to see people that start TensorFlow, in this case, that did not start Free Code Camp, where else did they start? And you can find all of these machine learning projects that are related. You can run the same with your projects. Who is your audience? What else are they starting? I'll be very happy to run this for your project if we have time. You can have a timeline of stars. This is, for example, for Apache projects. You can see that most projects get stars in a regular way, in this case, for the top 10 Apache projects. But there are others that have this huge jump in the number of stars during some days. You can play with this too. I created this with Data Studio. This is our free visualization tool that you can connect to BigQuery, to a lot of other sources, and run, and you can publish interactive visualizations. I can come back here if we have time. This is, for example, a visualization of Flink versus Arrow. You can see that Flink got a regular number of stars during this timeline, but Arrow got a lot of stars every time Wes McKinney wrote a blog post. In this case, these other projects, the annotations here are each time that these projects got featured on the Hacker News front page. So if you get on the Hacker News front page, you will get a lot of stars. To run these annotations, I did not add them by hand, but I also happen to have Hacker News on BigQuery, so I could just run this join between GitHub and Hacker News and start getting my charts interactively at any moment. Feel free to play with this. Project Health. These, for example, are the repositories with the most comments on issues during this month. Kubernetes got a lot of comments, AppSpark got a lot of comments, Origin, OpenShift, Sauron demo. Again, who knows this project? Again, we need to be suspicious about where is our data coming from. You don't want to know the ones that have the most comments, because all comments could be written by one person or a robot, which is the case with this project. So let's look at the number of authors writing comments. Kubernetes, 500. React Native got more people, 600. Font Awesome, 640. But instead of ranking by the number of people, now I'm ranking them by the number of comments per author. So you can see that in Kubernetes, these 500 people each wrote about around 18 comments. While in Font Awesome, each one wrote less than 2 comments. And this shows you that this community is way more active. People are coming back, they are discussing, they are engaged in the conversation. So you could see this as when I run this query, the healthiest projects community-wise on GitHub, which is pretty cool, and you should be measuring for your project too, or for the projects you want to choose. You can do text analysis. These are the top ways, the top 4 words when you're starting an issue. It would be nice. Is it possible to? People on GitHub are really nice. And this is the proof. Yeah, but are you effective? Exactly. How many of these issues get closure? So if you say it would be nice, you get 56% closure. If you say, I get the following, you get 86. So the more clear you are, the more precise of what is your problem, what do you want. Sorry. You were trying to be, yes. Cool. But, so yes, I was trying to, which is 13. Yes, that's more effective than I would be nice. At least you're saying what you're trying. But between I get the following and I was trying, I get the following is the one that works. This is what I have. Let's continue. Top countries. Of course. Top countries, no. Because I'm taking this data from the GitHub torrent data, GHTorrent, and they are looking at your profiles. What did you write as your country in your profile? So if you go to, let's see, me, where am I? I removed it. Wherever you put in your profile, I have that I live in San Francisco, California. GHTorrent will take that data and try to normalize it so we can run stats. Top country? No. But then the next country is, of course, you know, the US, China, so India, China, Great Britain, which are big countries. So this, again, is an unfair ranking. What are the top countries encoders per capita? So this is a map of the same data. Of course, the United States is the greenest, the deepest color. But if we normalize by population, you can see that North Europe shows a big concentration of programmers. The ranking is the top countries. In ratio are Iceland, Sweden, Norway, New Zealand, Denmark, cold countries. That's the idea. Now, if you start talking about cold countries, you really want to visualize this. And I have all the worldwide weather for the whole world stored in BigQuery for every station that I found. So where would programmers prefer to go, cold countries or hot countries? I know where you prefer. You look happy. Yeah. So this is for every weather station I have around the world, the average temperature for each station graphed. Singapore is here, you must be around here. Venezuela is here, and you must be one of these other countries. And if you join both data sets, you get a chart like this, where the coldest countries have the highest concentration of programmers. Singapore is hot, but has a high concentration too. But you can see a correlation, and Dominican Republic is here. It's hot, but between the hot countries is way above average, at least by that mean. Right next to Puerto Rico, Brazil. It kind of makes sense. And it's cool to see yourself like, yeah, we do have here a high concentration of programmers compared to the rest. This is not from GitHub, but since we are in the Python conference, I wanted to show this. I added these slides this morning. We also have every pip install logged into BigQuery. The Python Software Foundation, Donald Staft, is doing this. So he has done this for 683 days. For example, yesterday there were 26 million downloads, 8 gigabytes of data, and you can count how many pip installs of your favorite projects happened yesterday. My friend Tim Swast left a lot of queries. Let me show you quickly this. How are we doing on time? How much time do we have left? We have 30 minutes left? 1-3, okay. So, yes, 1-3, 13. Gracias. So Tim left here a cool notebook with this kind of queries for you to see how you can interact with BigQuery from IPython too. So please try stuff. move quickly through this, but what I wanted to show you is the query I just ran 10 minutes before starting this presentation. What are the top installs that from this year compared to things that were not top installs a year ago? So this is my query, top number of installs, where in 2017 January, we was not on the top 500 ranking. The top new package is AS1 Crypto, Seaborn, Pendulum, PyTZ Data, Google Cloud Storage, Pinnacle, Google, Apache Beam, CCXT, OpenCV Python, and you might recognize, so for example, AS1 Crypto right now is in the position number 40 of number of downloads. A year ago, it was in the position 4,000. So it really got popular really, really fast. While some things a year ago were not even in the ranking. Yeah. I hope you find this cool. Anything that makes sense? Yeah? I just ran this query 10 minutes ago, and I was happy to see the results. Now, last 10 minutes, where is the code? We also took all of the code on GitHub, open source code with an open source license. We put it on BigQuery. Now you can analyze code. When I took this screenshot, we had almost 2 terabytes of data. Now it's more, 200 million rows. And you can find the contents of files. Like for each file, each ID, we have the size, the content, and the number of copies. Why? Because for each unique file, we only store 1 copy. So if you multiply the number of files by the size, you get to more than 46 terabytes of data. That's a lot. So rules when running this kind of analysis, remember to extract first. Like if you want all of the Python code, extract first all of the Python code so you don't analyze 2 terabytes of data each time. You do it that once, and then you run all of your analysis over that. In fact, I already did it because I wanted to analyze Python code. I extracted it. I'm sharing it with you. We only have open source projects, and the open source, our open source team is very adamant about this. Your project needs to have an open source license. Otherwise, we cannot copy the files out. For example, let me do this with Java. These are the top imports in Java that had the top growth between 2013 and 2016. What about Python? Again, I extracted 8 gigabytes of Python code. I extracted 8 gigabytes of IPython notebooks. You can analyze now the code there. These are the top imports from Python files: auth, sys, re, time, JSON, logging, datetime, random. Number 10 is unit test. So people are doing their unit test, but only 54,000 projects versus 200,000 projects doing other kinds of stuff. Close to unit test, NumPy, etc., etc. I'm doing this just by looking at the Python files, so I'm happy about that. Stack Overflow, you can find all links that people put on Stack Overflow on Python code to Stack Overflow. So this is JavaScript, but in Python, the top question linking to Stack Overflow is how to import a module from a relative path, test if an executable exists in Python. Like you can see, this also have a lot of views, and I know all of this because I also have Stack Overflow on BigQuery. You can run these joins. It's pretty easy, and you can get interesting results. What happens the other way? Anyone copies code from Stack Overflow to GitHub? That was Sebastian's question. Not everyone does that, but he wanted to know if someone does. So he looked at this popular question, how to do this in Java. And how do you find this code if you wanted to find the number of copies? Some people change the name of the variables, they change the indentation. It's not easy to do. So he transformed it into a regular expression. Yes. And it worked, because BigQuery can work with this regular expression. He found it in 500 files, and only 27% gave credits. And if you don't give credits to the code you copy, Sebastian will find you. So please, give credit when you copy code. Respect the license. Requesting features, I love this one. From someone wanted to change the Go language. So the library offers after expiration time, sub time now. They wanted to write after time until. Should they, or should the Go team implement this? Well, Francesc, my ex-teammate, but who's still doing cool stuff, took the Go files content, and he looked for how many people are doing this. And it turns out 2,000 repositories would benefit from this feature, and the Go team implemented this. For a different request, Francesc determined that 700 repositories would be broken by this change, so the Go team didn't implement this. So whenever you have requests, you can use data to make your request. And even better, if you want to vote, just by putting your code on GitHub, you are voting. By open sourcing your code, someone else can use it as a vote of things should be done or not, because other people can analyze it, and that makes me so happy too. You can go beyond regular expressions. BigQuery can run JavaScript code. So in this case, I took a JavaScript analysis, JavaScript code analysis tool. This is a Python JavaScript library, JS hint. I can take it, I can run it inside a query, and there I am running JavaScript code and doing static code analysis of code. You can do this too. Spaces or tabs, spaces people versus tabs people. Everyone has an opinion. We can go and find what's more popular. These were my rules. You can find all of my rules later. This is my code. First extract, then analyze. Tabs versus spaces, language by language. Spaces is way more popular. In Python, very few people do tabs. In Go, everyone does tabs. In Ruby, even less people do tabs, but you can find these results. This is another huge operation from our open source team. They found a the Mad Gadget vulnerability in a lot of repositories. A huge group of Googlers started looking at all of these projects, finding them with BigQuery, and sending pull requests to fix this. And I'm very, very proud of them. SQL, where do you put your commas? How much time do we have? 6 minutes, cool. Anyone puts their commas at the end? Okay, at the beginning? That's ugly. I do this too. The thing with Python? Yes. Well, I love writing SQL. So the problem is that any language will allow you to put a comma here. Python has no problem with a comma at the end. But SQL will not run a query if I put a comma here. So that drives me crazy. So I started putting my commas at the beginning, so now I can comment and comment these lines. Now, what is more popular? This is Fine Smart Query running the most popular. The most popular, as shown by your hands, is most people put their commas at the end. Done. I lose. So, exactly. So the question really is, which projects are more successful? Yes. So, and how do you define success? Number of stars last year, contributors, activity, blah, 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 blah. My query, my results, projects that allow you to put leading commas are double as successful as the projects that don't. Yes, put your commas at the beginning. I just proved why. And find me with data, write another query if you think you can prove me wrong. So who wants to analyze GitHub? I hope all of you. Even GitHub uses GitHub BigQuery to analyze GitHub. I have this video with Alison La. She's a data scientist at GitHub. Everyone wants to, hopefully you. There's a lot of people that have published results. please publish yours, put them on Twitter, send them to me. Find this material there, find me on Reddit, find me on Stack Overflow, find me on Twitter, and I love feedback if you want to give me feedback. Thank you very much.